Welcome to clickmateprojects.com. Here we discuss about a low complexity turbo decoder architecture for energy efficient wireless sensor networks. One of the major challenges as the physical layer of wireless sensor network is in usage of appropriate channel coding schemes to protect transmitter messages and achieve a desired bit error rate. While maintaining low complexity and low power consumption, features are sensor nodes. In this architecture, we refer to sensor nodes as tiny self-powered boards with sensor, radio and processing power. Turbocars have been shown to achieve near Shannon limit error correction. However, turbo decoding is too complex to be implemented on a single wireless sensor with its limited hardware resources and power constraints. In this paper, a distributed algorithm for turbo coding and decoding is proposed that distributes multiple convolutional codes and iterative decoder structure into various sensor nodes in the heterogeneous wireless sensor network. This is similar to concentrated codings, but instead of having all constituent codes on the same sensor node, they are distributed over several sensor nodes. This approach poses several challenges as outlined in this paper. The encoder structure is a parallel concentrated convolution code with random distributed in several sensor nodes. A simplified map decoding algorithm is used to build a number of blocks formed by concentrated soft decoder of the constituent codes generated at the encoder cell. In this paper, we propose a novel LUT log BCJR architecture for energy constraint scenarios, which avoids the wastage of energy that is inherent in the conventional algorithm. The philosophy is to redesign the timing of the conventional architecture in a manner that allows its components to be efficiently merged. This produces an architecture comprising only a low number of inherently low complexity functional units which are collectively capable of performing the entire LUT log BCJR algorithm. Further wastage is avoided since the critical parts of our functional units are naturally shortened equally length, eliminating the requirement for additional hardware to manage them. Furthermore, our approach naturally results in a low area and high clock frequency, which implies low static energy consumption. As we will show in the LUT log BCJR algorithm is naturally suited to this philosophy, since it can be decomposed into classical ACS operations. We tackle the challenge of devising an architecture that is sufficiently flexible for performing the entire LUT log BCJR algorithm using only a small number of functional units. Now I am going to describe the flow diagram of our project. Here we provide the encoding and decoding methodology by using log LUT based BCJR algorithm. So here we provide the architecture designs of our proposed work in the Xilinx simulator. Here we give the input as a 8-bit vectors without using the direct given input of a signal. So for the input bits are loaded as the input register in the initial condition. Then these are arranged in the registers of input buffer to get the extracted output and performs the delay operations of previous and present stage extraction in BCJR algorithm. Then this result was given back to the adder algorithm, because here we using the ACS architecture designs to provide the add and compare and select the ranges of bits according to the input signal ranges. Then here we extract the LUT creations to provide the signal capturing of each and every ranges of cosine and sine wave ranges. According to that LUT, it collects the informations of previous and present informations of the signal as the given input. This gets the collection informations and combine the architecture designs and extract the BCSAR algorithms to checking whether there was any errors or made during the transmission stage, and this was given back to the BCGR decoding step. Here it decodes the input binary signals and finally a decoder outputs are fed back to the output register. Thus we decode our message of the end. Now I am going to describe the running procedure of our project. Here in the initial cases we check the syntax if there are any errors proposed in the coding, and we extract the RTL schematic diagrams and technology schematic diagrams, and finally we view the timing diagrams of our proposed work. So in the initial case, select the implementation option and select the main function and double click check syntax to run the syntax error checking. This check each and every lines in our codings which are represented in BCGR algorithm and finally displays in the console window. After completions, the tick option will be displayed. And after that, we view the RTL schematic by run the view RTL schematic. This will display the logical circuit designs of our proposed work according to the coding structure. This gets the internal structures as a logical flip-flops and the LUT's concept-based circuits. Then click the Add and click Create Schematic. This is our overall RTL schematic diagrams of our proposed work. In the initial case, the input was D input and clock, enable and reset. Output will be 32-bit or and output enable bits. We can view the internal structure of our BCG algorithm by double click it. This is our internal structures of our BCGR algorithm. We can view the technology schematic diagram by run view technology schematic. Click add and click schematic. We can view the technology schematic internal structure. This will display the LUTs and the flip-flop based architectures and the buffer based connections. Now I am going to explain the timing diagrams of our project. In this case, select simulation option, select our main function and run simulate behavioral model. In this case, this will display the timing diagrams of our proposed work which creates a guide preparations of iSIM simulator. Here we are using iSIM simulator to view the timing diagrams of our proposed work. This will display the input and output pin details and the internal signal architecture outputs also present in their coding. After elaborating, I give the clock signals as initial to 0 and give the enable as 1 and reset as 1. In initial case, the reset will be set to 1 and I give encoded bits as a data inputs and click the run for the specified on the toolbar. Afterwards, I give the positive edge for clock period. This provides the resetting conditions of our initial condition. Then I give the reset to 0 and vary the clock to 0. After I change the clock periods at positive stage, this will then generate the decoded results. This is our running procedure of our project. Thank you.